Good afternoon, everyone. Welcome to the lecture of number 3. In last lecture, we have completed our first unit, which is a divisibility theory. Now, today we are going to study the next unit, which is a congruence theory. Okay. Screen is visible.
Yes,
Yes,
sir.
sir.
Is the screen is visible?
Yes, sir.
Yes, sir.
स्क्रीन शेअर केलेली दिसली का?
हो, सर.
Yes, sir.
आवाज येते ना माझं?
Oh, sir.
हो, सर.
Unit second. Okay, now we have to see what is a congruence theory. Okay, actually congruence theory is another approach to divisibility theory. Here also we have to use the divisibility theory only. What is meant by divisible? Any two integers are said to be divisible with आवाज येते ना माझा तुम्हाला?
थोडासा लो येत आहे सर.
हॅलो,
Yes, sir.
आवाज येते का?
Oh, sir.
Yes, sir.
हो, सर.
What is mean by divisible?
सर, ए आणि बी दोन इंटिजर्स असतील तर देअर
Yes.
एक्झिस्ट अ पॉझिटिव्ह इंटिजर सच दॅट वन इज रिटन इन द मल्टिप्लिकेशन ऑफ दॅट सम इंटिजर अँड बी.
Yes. Okay. Now we have to see what is an congruence theory. Actually, congruence theory was first introduced by the German mathematician Carl Friedrich Gauss. Okay, this concept was first introduced by Gauss, and in this chapter Gauss introduces the concept of congruence and the notations that makes it to such a powerful technique. Okay. Now, what is meant by congruence? That is, if we have given two integers a and b, then when they are said to be congruence, according to Gauss, the number n that measures the difference of two number a and b with respect to n is nothing but the congruence of a and b. A and b. That is, if we have suppose given two integers a and b, then these two integers are congruent modulo n with respect to this integer n if this n divides the difference of these two integers a and b, which is the, let us first define what is the congruence. Okay, see what is its definition. Okay, let n be a fixed positive integer, two integers a and b are said to be congruent modulo n if the integer n divides the difference of a and b, that is, if n be any positive fixed integer and a and b are any two integers, then these two integers a and b are said to be congruent modulo n if n divides the difference of these two integers a and b. That is, if n divides a minus b, then we say that a and b, a is congruent to b modulo n, and which is denoted by the symbol a is congruent to b modulo n. And when we say that a is congruent to b modulo n, if n divides a minus b, if n divides a minus b, then we say that this a is congruent to b modulo n. Now, by the definition of divisible, if n divides a minus b, which implies there exists an integer q such that n into q is nothing but a minus b. Okay, and this one is the definition of your congruence. Okay, now let us take some examples. Okay, first one. Now we have to check whether 3 is congruent to 24 modulo 7. Here we have to check whether integer 3 is congruent to 24 modulo 7. But by the definition of congruence, any two integers are said to be congruent modulo n. That is, if a and b are any two integers, then a and b are said to be a is congruent to b modulo n if n divides the difference of two integers a and b. So as here a is 3, b equal to 24 and n equal to 7. If we have to check 3 is congruent, 3 is whether congruent to 24 modulo 7 or not, we have to check whether this 7 divides the difference of these two integers 3 and 24. Let us check. 3 minus 24 is nothing but minus 21, and we know that 7 divides minus 21, that is 7 divides the difference of these two integers a and b, where a is nothing but 3 and b is nothing but minus of, sorry, b is nothing but 24, and 7 divides minus 21, therefore this 3 is congruent to 24 modulo 7. Second one is, let us check whether minus of 15 is congruent to minus of 64 modulo 7. Whether this one is also correct? Check. Here we have to check whether 7 divides minus of 15 plus 64. What is the value of minus 15 minus of minus 64? Which is nothing but minus 15 plus 64 equal to
49.
64 minus 15.
49.
49.
49, sir.
49. Whether 7 divides 49?
Yes, sir.
Yes, sir.
As 7 divides 49, which implies minus 15 is congruent to minus of 64 modulo 7. Okay, now there is one note. If n does not divides a minus b, then we say that the integers a and b are not congruent. Okay, as the definition of congruent itself says that any two integers a and b, such that when we say that a and b is congruent to b modulo n, if n divides the difference of these two integers a minus b. As here already given that n does not divides a minus b, then we say that these two integers a and b are not congruent. Let us take one example, and which is denoted by, first let us see what is its symbol. एकच मिनिट बरं का. Okay, now this, and it is denoted by the symbol A is not congruent to B modulo. Yeah, for example, let us check whether 5 is congruent to 1 modulo 3. We have to check this one, whether this one is correct. If we have to check 5 is congruent to 1 modulo 3, then this 3 must divide 5 minus 4, 5 minus 1. Whether 3 divides 5 minus 1,
No, sir.
as 5 minus 1 is nothing but 4 and 3 does not divides 4, which implies 5 is not congruent to 1 modulo 3. Okay, now this one is the first node. Let us take second one. Two integers A and B are congruent modulo 2, congruent modulo 2 if both A and B are uh, either even or odd. Okay, now we have to check whether this one is correct. According to this statement, any two integers A and B are congruent modulo 2 if and only if both A and B are either even or odd. If we take one, first let us take by taking either even or odd. Two, if any two integers A and B, let us take A equal to 4 and B equal to 6. Now we have to check whether this 4 and 6 are congruent modulo 2, as here n is equal to 2. Here n equal to 2. So, and 2 divides 4 minus 6, which is nothing but 2 divides minus 2, which is for both even, that is either both A and B are even, then 2 divides difference of these two even integers. And similarly for odd, since the difference of two odd number is again a even number. For example, if we take A equal to 9 and B equal to something 5, then A minus B is nothing but A minus B is nothing but 9 minus 5, which is equal to 4, and 2 divides 4. Therefore, the two integers A and B are congruent modulo 2 if both A and B are either even or odd. If instead of this one, if we take one number is even and another is odd, then what should happen? If suppose if A equal to something 6 and B equal to 11. Now we have to check whether this A is congruent to B modulo 2. For that we have to check whether 2 divides its difference, as A minus B, which is equal to 6 minus 11. 6 minus 11 is nothing but minus of 5, and we know that 2 does not divides minus of 5, which implies A is not congruent to B modulo 2 for all such integers in which one number is even and another is odd. कळतंय का हे सगळ्यांना?
हो सर.
जर दोन्ही ऑड असतील तर काही प्रॉब्लेम नाही, दोन्ही ऑड असतील तरी कॉन्ग्रुएंट असतील ओव्हर मॉड्युलो 2. दोन्ही इव्हन असतील तर होईल, कारण दोन इव्हन नंबरचं सबट्रॅक्शन घेतलं तरी इव्हनच येईल, आणखी दोन ऑड नंबरचं सबट्रॅक्शन घेतलं तरी इव्हनच येईल. परंतु एक इव्हन आणि एक ऑड जर घेतला तर त्यांचं सबट्रॅक्शन ऑलवेज ऑड येईल आणि 2 त्याला कधीच डिवाइड करणार. ओके, नाव if or let n be, sorry, a be a given integer, let a be a given integer, any given integer, and q and r be its quotient and remainder when divided by n. Okay. If we take any integer a and q and r be its quotient and reminders, when we divide this a by n, then we get the quotient q and remainder r. As here given that quotient and remainder, then we can easily apply the division algorithm. Then by division algorithm we get division algorithm, a is nothing but, as we divide this a by n, then it is a multiple of n plus something remainder, where range of r is nothing but 0 is less equal by r, which is less than n. Okay, this one is according to division algorithm. This can be written as a minus r is equal to n into q. Now we here apply the definition of divisibility. As a minus r is a multiple of n, then we can divide this a minus r by n, which implies n divides a minus r. And now here we apply the definition of congruence. N divides a minus r, that is an integer n, which is a fixed positive integer n, which divides the difference of two integers a and r, which implies a is congruent to r modulo n, which is from the definition of congruence. Okay. Now, what are the possible values of r? As r is a remainder which is obtained by when we divide this integer a by n, then what are the possible values of r? The possible values of r are values of r are 0, 1, 2, 3 up to so on n minus 1. These are the only possible values for r, since as r is a remainder, when we divide this a by a fixed positive integer n, then the possible values of r, that is 0, 1, 2, 3 up to so on n minus 1. Therefore there are n possible values of r. Okay, now we say that the integer a is congruent modulo n to one of these n values, 0, 1, 2 up to so on n minus 1. Okay, as we take any integer a and we divide it by n, then the possible values of r are 0 to n minus 1. That is, there are n possible values for the remainder r. Okay, now in particular a is congruent to 0 modulo n. If a is congruent to 0 modulo n, which implies n must divides a, since as here a is congruent to 0 modulo n, then n divides the difference of these two integers a and 0, that is n divides a. And according to definition of congruence theory, if n divides a, which implies a is congruent to 0 modulo n, therefore this one is the if and only statement. Therefore a is congruent to 0 modulo n if and only if n divides a. Okay, and the set of integers 0, 1, 2 up to so on n minus 1 are called least non-negative reminders modulo n, since which is obtained by division by n to the integer a. Okay, that is residues. Okay, these n integers are called residues. Okay, now a collection of n integers a1, a2 up to so on, an is said to form a complete set of residues modulo n if every integer ak whenever k lies between 1 to n is every integer is congruent modulo n2 exactly one of the integer 0, 1, 2 up to so on n minus 1. What are the residues? We have actually known that what are the residues. If a is congruent to r modulo n, then the possible remainder values are n values, that is 0, 1, 2 up to so on n minus 1. And this set of these n integers are called residues. And if we take any collection of n integers a1, a2 up to so on an, then this collection of n integers is said to form a complete set of residues modulo n if every integer ak, that is every integer among this n integer is congruent modulo n2 exactly one of the integer 0, 1, 2 up to so on n minus 1. If suppose a1 is congruent to 0 modulo n, a2 is congruent to 2 modulo n, a3 is congruent to 1 modulo n, and so on. That is, here we have to check whether each integer is congruent to different remainder. If each integer among these n integers are congruent to different reminders, then we say that this corresponding set of these n integer is said to form a complete set of residues modulo n. For example, let us take this set which contains the elements minus 12, minus 4, 11, 13, 22, 82, and 91. How many numbers are there? There are 7 numbers. That is, here n is equal to 7. Okay. Now we have to check whether this set forms a complete set of residues modulo 7. And we know that when we say that the set forms a complete set of residues modulo n, if each integer among these n integers, as here 7, each integer among these 7 integer is congruent to different remainder of this element 7, that is the remainders obtained by division by 7. As here n is equal to 7, then the possible remainder values are, which implies the possible remainder values are 0 to 6. Possible values of remainder are 0, 1, 2, 3, 4, 5, 6. That is, these are the 7 possible values. Okay. 0, 1, 2, 3, 4, 5, and 6. These are the possible values of remainder. Now we have to check whether these 7 integers are congruent modulo n to one of these 7 integers, and each integer is congruent to different remainder. Okay. Now check whether this one is possible. Minus 12. Minus 12 is congruent to which integer? Modulo 7. Minus 12 is congruent to, minus 12 is actually nothing but this one is 5. 5 is congruent to, minus 12 is congruent to, whether minus 12 is congruent to 0 modulo 7. Minus 12 minus 0, which is minus 12, and minus 12 is not divisible by 7. Therefore, minus 12 is not congruent to 0. Whether minus 12 is congruent to 1 modulo 7. Minus 12 minus 1 minus 13, and 7 does not divide minus 13. Therefore, minus 12 is not congruent to 1 modulo 7. Whether minus 12 is congruent to 2 modulo 7.
No, sir.
Why?
Because
minus
7 does not 10.
7, whether 7 divides minus 12 minus 2. As minus 7 divides minus of 12. Minus b is nothing but minus 2, which is nothing but minus 14. 7 divides minus 14.
Yes, sir.
7 डिवाइड करतो का -14 ला?
Yes, sir.
As 7 divides -14, which implies -12 is congruent to 2 modulo 7. Similarly, we have to check for remaining integers. -4 is congruent to -4 -0. 7 does not divide -4. -4 -1. 7 does not divide -5. -4 -2 -6. 7 does not divide -6. -4 is congruent to 3 modulo 7, since 7 divides -4 -3, which is -7, which implies -4 is congruent to 3 modulo 7. Similarly, 11 is congruent to 4 modulo 7, since 7 divides 11 minus 4, which is equal to 4. Okay, now next one. 13 is congruent to 6 modulo 7. Similarly, 22 is congruent to 0, not possible, 1. 22 is congruent to 1 modulo 7, since 7 divides 22 minus 1, which is 7 divides 21. 82 is congruent to 82 is congruent to 82 divided by 7. What is the remainder? 77. 77 means 5 is the remainder, which implies 82 is congruent to 5 modulo 7. Similarly, 91 is congruent to, as 7 divides 91. Okay, whether 7 divides 91,
Yes, sir.
as 7 divides 91, which implies 91 is congruent to 0 modulo 7. Therefore, these 7 integers, -12, -4, 11, 13, 22, 82, and 91, congruent to different reminders, since no two integers among these 7 integers are congruent to same remainder. Therefore, from this we say that from the definition of complete set of residues modulo n, this set, which implies the set which contains the element -12, -4, 11, 13, 22, 82, and 91, forms a complete set of residues modulo n. Forms a complete set of residues modulo 7. कुणाल काही डाउट आहे यार?
No, sir.
No, sir.
Okay. There is one short note. Any n integers are any n integers forms a complete set of residues modulo n if and only if no two integers are congruent modulo n to the same remainder. जर प्रत्येक इंटीजर त्या n इंटीजर मधला वेगळ्या रिमाइंडरला जर कॉन्ग्रुएंट होत असेल तर ते करस्पॉन्डिंग सेट कंप्लीट सेट ऑफ रेसिड्यूज मॉड्युलो n फॉर्म करेल. ओके, नाउ देयर इज वन theorem for any arbitrary integers a and b, integers a and b, a is congruent to b modulo n if and only if a and b lose the same remainder when divided by n. So here we have to prove that this one is the theorem. Okay, for any two arbitrary integers a and b, we have to show that a is congruent to b modulo n if and only if the integers a and b lose the same reminder when it is divisible by 2. Part 1, that is only if. Okay, a is congruent to b modulo n. Suppose that a is congruent to b modulo n, and from the definition, if a is congruent to b modulo n, which implies n divides a minus b, which is from the definition of congruence. Okay, as n divides a minus b, which implies there exists an integer k such that n into k is equal to a minus b, which implies a is nothing but b plus n into k. Let's take this one as a equation 1. Now we have to prove that second part, which is to prove that a and b lose the same reminder when divided by n. Okay, divided by n. Okay, let us suppose that an integer b gives the reminder r when divided by n. Okay, if we divide an integer b by n, then it gives the reminder r. Then by division algorithm, this one is nothing but b is nothing but n into some q plus r. This one is our supposition where 0 is less equal by r, which is less than n. Okay, now as here we have taken the reminder for b is r, as now we have to check whether r is also the reminder for a or not. Okay, now as here b equal to n q plus r, here we get the value of b. Now we have to put the value of b in equation 1. Then we get put b equal to n q plus r, put b equal to n into q plus r in equation 1. Okay, we get a is equal to b is nothing but n into q plus r plus n into k as it is, which is nothing but a is equal to, take n common, which is nothing but q plus k plus r, which is nothing but a equal to n into q dash plus r, where q dash is nothing but q plus k. As q and k both are integer, then its combination is again an integer, therefore q dash is an integer. As here we have expressed a as a multiple of this n plus some reminder. As here we get the reminder of a is also r. Here this shows that when we divide a by n, then it gives the reminder r. Therefore here the reminder of a and b is same. So if a is congruent to b modulo n, which implies a is congruent to b modulo n, then a and b lose the same reminder. Okay, so first part will be proved. Now in second part we have to assume that a and b lose the same reminder, and we have to prove that a is congruent to b modulo n. Now we have to check the if part. assume that or suppose that A and B leaves the same reminder, same reminder when divided by n. Okay, this one is our supposition, that is A equal to some n q1 plus r, where 0 is less equal by r, which is less than n. Let us take this one as equation 2, and B equal to n into q2 plus remainder is same, where 0 is less equal by r, which is less than n. This one is the third one. Okay, now we have to prove that A is congruent to B modulo n, and for that we have to check whether n divides the difference of these two integers A and B. For that, let us subtract equation 3 from 2. We get subtracting 3 from 2, we get A minus B is equal to n q1 minus of n q2 plus r minus of r, which is nothing but A minus B is equal to n into q1 minus q2, where plus r and minus r gets cancelled. Therefore, now here we have to use the definition of divisibility, as A minus B is a multiple of this n, that is, take this one as a n into some k dash, where k dash is nothing but q1 minus q2. Therefore, A minus B is nothing but n into k dash. Then by the definition of divisibility, n divides A minus B. As n divides A minus B, then here we have to use the definition of congruence, which implies A is congruent to B modulo n. So in second part, we have taken that A and B leaves the same remainder when divisible by n, and we have proved that A is congruent to B modulo n, and its converse part we have already proved in part 1. Therefore, from this one we conclude that for any arbitrary integers A and B, A is congruent to B modulo n if and only if A and B leave the same remainder when divided by n. Let us take some examples depending on this theorem. Example, first one, minus of 56 is congruent to minus of 11 modulo 9. We have to check whether minus of 56 is congruent to minus 11 modulo 9, and we have to use the above theorem. Now express minus 56 as a multiple of this 9 plus something remainder. Minus 56 is nothing but, as minus 56 is nothing but 9 into minus of 7, 9 into minus 7, minus of 63 plus 7. Whether this one is correct? 9 into minus 7 is minus of 63, minus 63 plus 7, which is minus 56, and minus 11 is nothing but 9 into minus 2, minus of 18, minus 18 plus 7, which is equal to minus 11. As here these two integers minus 56 and minus 11 lose the same remainder, which is 7 when divisible by an integer 9, as they lose the same remainder, and above theorem is a if and only if. Therefore, as here the remainder is same, which implies minus 56 is congruent to minus 11 modulo 9. Okay, now let us take the second example. Check whether 31 is congruent to minus of 10 modulo 7. Okay, now here we have to check whether 31 is congruent to minus 10 modulo 7. 31 can be expressed as, 31 is nothing but 7 into 4, 7 into 4, 28, 28 plus 3. Okay, so this one is the remainder is 3. Minus 10 is nothing but 7 into 2, 7 into minus 2. 7 into minus 2, minus of 14, minus 14 plus 4. Whether the remainder is same. Remainder same
No,
आएगा.
sir. No,
As
sir.
No,
3 are different, which implies as 31 and minus 10 leaves the different reminders when divided by 7, which implies 31 is not congruent to minus of 10 modulo 7. Okay. Now here is one note. If A1, A2 up to so on AK forms a complete residue system, complete residue system modulo n, then n must be equal to k. Actually, this note is depending on the complete residue system. If suppose there are k integers a1, a2 up to so on ak, and they forms a complete residue system modulo n, then this n is must be equal to k. For that, let us take examples. Check whether the following set forms a complete residue system, complete residue system modulo 6. Okay, for that let us take first one, and in that we have to take the set which contains the elements first one 5, 12, minus 3, minus 4, 7 and 22. Now we have to check whether this system set forms a complete residue system or not. Now as here n is equal to 6, then the possible values of r are nothing but 0, 1, 2, 3, 4 and 5. These are the only possible values of remainder. Now here we have to check whether these 6 integers are congruent to different reminders or not over modulo 6, that is when divisible by 6. Now 5 is congruent to 5 modulo 6, 5 minus 5, 0, and 0 is divisible by 6. Similarly 12 is divisible by 6, which implies 12 is congruent to 0 modulo 6. Now next one is minus 3. Minus 3 is congruent to plus 3. Sorry, minus 3 is not yes, minus 3 is congruent to plus 3. Minus 3 minus 3 minus 6. Okay, modulo 6. Again minus 4 is congruent to 2 modulo 6. Similarly 7 is congruent to 1 modulo 6, and 22 is congruent to 4 modulo 6. So here each integer, my 5, 12, minus 3, minus 4, 7 and 22 are congruent to different reminders, and as here 6, here n is equal to 6 and k is nothing but 5, since k is equal to 6, since there are 6 integers. Therefore as here k is equal to n, so the set 5, 12, minus 3, minus 4, 7 and 22 forms a complete residue system modulo 6. Modulo 6. Now there is one more example. Second one. the set which contains 49, 20, 10, 17, minus of 18, and minus of 26. Here also n is equal to 6. Now 49 is congruent to 49 is congruent to 1 modulo 6. Okay. Whether 49 minus 1, 48 is divisible by 6. 48 divisible आहे का 6 ने?
Yes.
Yes, sir.
20 is congruent to 2 modulo 6. Okay. Now 10 is congruent to
4.
4 modulo 6. 17,
1 modulo 6.
whether 6 divides 16. 17 is congruent to 5 modulo 6.
5.
Yes. Minus 18 is congruent to 0 modulo 6. What about minus 26? Minus 26 is congruent to, again it is congruent to 2 modulo 6.
2 modulo 6.
Whether 6 divides minus 28.
No, sir.
Then minus 26 is congruent to
4.
4 modulo 6. Minus 18 is congruent to 0 and minus 26 is congruent to 4 modulo 6. As here the integers 10 and minus 26 are congruent to same reminders. Reminders same आहेत काय दोघांचे?
Yes, sir.
Yes, sir.
As the reminders are same, then the set which contains the elements 49, 20, 49, 20, 10, 17, minus 18, and minus 26 not forms a complete residue system modulo 6. Not forms a complete residue system modulo 6. कुणाल काही डाऊट?
No, sir.